This lecture is on similar polygons. So first of all, let's talk about similarity. Similarity is basically the same shape, but not necessarily the same size, which would mean congruency. So to have similar polygons, similar shapes in general, you need the corresponding angles to be congruent. That's one part of it. And you need corresponding sides to be proportional. And that's really why we did this previous section on ratios and proportions for this second part. So two parts: corresponding angles congruent, corresponding sides proportional, and the correspondence is important, which we'll get to in a moment. The similarity ratio is a ratio between the two similar figures, and it's a proportion between those two, a ratio between those two, and it's a length ratio. It refers to different lengths, not, say, areas, which comes up later. A similarity statement is like a congruency statement that we did several chapters ago, in that the order of the letters indicates the correspondence between the two different shapes. So let's go on a little more detail now. So two polygons are similar, that is, this symbol here is similar, if their corresponding angles are congruent and their corresponding sides are proportional, and that proportion is called the similarity ratio. It's a length ratio, also sometimes called the scale factor. So same shape, but not necessarily the same size. Now, as far as an actual similarity statement, supposing we had this similarity statement here. Quadrilateral ABCD is similar to quadrilateral WXYZ. Well, that means that A goes with W, B with X, C with Y, and D with Z. So, for instance, you could say, just from looking at this statement and not looking at any figures, you could say angle A is congruent to angle W, first letter, Y is congruent to C, third letter. You can also set up proportions with sides. You could say that AB divided by WX, that is 1, 2 over 1, 2, is equal to BC over XY, 2, 3, 2, 3. So we had left over right equals left over right, and the letters match up. So there's so many different ways to write proportions. That will be one source of confusion probably is, well, is my proportion correct? A lot of times what I may show would be a little different than yours, but they're both correct. They get to the same answer. Here's one more example. DA, so first and fourth, over BC. So now I'm going, instead of left to right, left, right, I'm doing left, right. You can do that too. So first and fourth over second and third equals first and fourth over second and third. So this one would be okay too, because the corresponding pieces match up when you look at the similarity statement. So here's another one, similarity statement, ABCD similar to WXYZ. And so here's ABCD, here's WXYZ. The angles are congruent. A is congruent to W, BX, C with Y, D with Z. A couple sample proportions. I could do bottom divided by right. That is one of these at a time. So the bottom is AB divided by the right BC, bottom WX, right XY. So instead of looking at the statement, now I'm kind of looking at the figures to get my proportions. Or I'll do little over big. I'll go left to right. So CD over, this is CD over YZ, right? Little over big is equal to AB over WX. So the pieces match up. So let's take a look at more problems related to this. Okay, so in these first problems, you are supposed to find out first, are the polygons similar? And if they are, you write a similarity statement and give the similarity ratio, and if not, well, why not? And so the way to figure out if they're similar, well, first of all, corresponding angles are congruent. 1 arc, 2, 2, 3, 3. Now let's see if the corresponding sides are congruent. So let's see, 14 is the biggest one on the left, divided by 7 is the biggest on the right. Is that equal to 12 over 6? And is that also equal to 10 over 5? And yeah, that's true. Those are all equal. And so the corresponding sides are congruent, the corresponding angles are congruent, corresponding sides are proportional. So now I can write a similarity statement. I'll do triangle ABC similar to triangle. A goes with X, B goes with Y, and C with Z. All right, over here, let's see, we do 5 over 3, so 5 divided by 3 equals 5 divided by 3. 5 divided by 3, and is that equal to 3 divided by 5? It's not. You always have to be consistent, left to right, left to right, left to right. And so that's no good. So these are not similar because the corresponding sides are not proportional. For number 4, we have 8 over 8 equals 8 over 8 over 8 over 8. So the corresponding sides are proportional, but the corresponding angles are not congruent. These are all 90, these are 60s and 120s. So this would be no. The sides are proportional, but the corresponding angles are not congruent. And over here, well, the angles are okay because we have one arc, right angle, right angle. Since we know they add to 180, the last angles must be the same. So the angles are okay. So now we want to check the sides and see if that works. So I'll do hypotenuse over hypotenuse of the big one is equal to 21 over, and this is opposite the angle, so 12 is opposite angle over 12. And the question is, well, is this true? Well, I can divide off a 5 here, and I'll get 7 over 4. Divide off a 3 here, and I will get 7 over 4. So the sides are okay. So the only question would be, does this match up with 16? And safe to assume it would be. Use the Pythagorean theorem. Okay. So for these problems, you have this similarity statement. You're shown the figures, which is nice, but you don't even need the figures for this. It's often good to have figures, but for this type of problem, the similarity statement has all the information you need. So angle M, second letter, congruent to angle I, second letter. Angle K, fourth letter, congruent to angle O, fourth letter. Angle N, third letter. Angle J, third letter. Okay, now we do side proportions. MN divided by IJ is equal to something over JK. Well, what's missing? Well, clearly that would complete it, so NO. So you can do these just sort of filling in the puzzle. It's nice to understand them, but you don't necessarily have to know what's going on. As long as you fill in the missing pieces. Okay, HI over LM, HI over LM, and that's equal to HK over something. Well, what's the corresponding piece over here? First and fourth, so that's LO. And then last one is IJ over MN. So IJ over MN equals HK, and then we're missing this LO. Okay, now we're told the polygons are similar. We want to find a value of the variable. So this way you've got to set up a proportion. So 5 over 6 equals 3.3 over x. You could also say 5 over 3.3 equals 6 over x. You could say x over 3.3 is equal to 6 over 5. Variety of possibilities. You cross multiply, you get 5x is 6 times 3.3. Divide both sides by 5 and get a calculator for that. Okay, for this one, again, there's often many ways to set up correct proportions. I'll do right over right. So 5 over 3 equals bottom over bottom, 8 over x. So I get 5x is equal to 24. Divide by 5. X is 24 over 5, 4.8. Okay, any more over here? No. All right, so now, given that triangle WXZ is similar to triangle DFG, we want to find out the following answers. Let's try to get everything here in one screen a little more. Okay, so the similarity ratio from WXZ to DFG. So you have to match up corresponding pieces. So from this one to this one, the only things that match up are the 4 to 6. So we can say 4 to 6, which goes to 2 to 3, or 2/3 if you prefer. If we want to find the length DG, actually let's first do angle Z. Angle Z is going to be congruent to angle G. Okay, well, angle Z, we do 180 minus 90 is 90. 90 minus 37 is 53. So that's 53. Angle G will be the same because those match up, G and Z, third letter, so that's 53. If we want to get DG, well, let's see. To get DG, this we do 3 squared plus 4 squared, and we get 5. It's a 3, 4, 5 right triangle, so we can set up a proportion to get DG. We can say 5 divided by 4 equals DG over 6. 5 over 4 equals DG over 6. I can cross multiply. 4 times DG equals 30. So DG is 30 over 4, 15 over 2, which becomes 7.5. GF, I'll get a proportion for that as well. So for GF, I can do 3 over 4. So right over bottom equals GF. So right over bottom, GF over 6. Cross multiply, 4GF equals 18. Divide by 4, and this becomes 9 over 2, which is 4.5. Angle D is the same as angle W. Those correspond, so that's 37 degrees. And then finally, WZ, well, I already got that earlier. That's just 5.